In this video, I am discussing KSET Mathematical Science previous year questions, real analysis on topic Riemann integration. If you want to practice more questions, join our Telegram group. Link is in the description. Check it once. KSET 2024 question. Let f from closed interval 0 to 2 r be defined by f of x equal to 1 for x equal to 1, 0 for x is not equal to 1, and g from closed interval 0 comma 1 to r be defined by g of x equal to 1 for x is rational, x is irrational, 0 for x is rational. Then f and g are Riemann integrable. 2. Neither f nor g are Riemann integrable. Third option, f is Riemann integrable, but g is not Riemann integrable. Fourth option, g is Riemann integrable, but f is not Riemann integrable. C. Question asked based on Riemann integrable. C. Riemann concept is Riemann integrable. Definition says, definition, a bounded function f is said to be Riemann integrable on AB if its lower and upper Riemann integrals are equal. Lower and upper Riemann integrals means lower Darboux integral and upper Darboux integral are equal. That means this is lower Darboux integral a to b f of x dx is equal to a to b f of x dx. This is upper Darboux integral. The common value of the common value of these integrals is called Riemann integral of f on AB and is denoted by integral a to b f of x dx. The interval a comma b, the closed interval a comma b is called the range of integration. The number a and b are called the lower and upper limits of integration respectively. And lower Darboux integral f of x dx is equal to supremum of lower Darboux sum. Here P is a partition. Partition P belongs to closed interval a comma b. Partition belongs to this. Next, upper Darboux integral is equal to infimum of upper Darboux sum. Here P belongs to partition P of a comma b. Now, first f given f from 0 comma 2 to r. F of x is defined like this: 1 if x equal to 0, 0 if x is not equal to 1. Here f is bounded and has only n plus 1, means 2 plus 1, 2 plus 1, or else here 0 to 2 is there, that's why. N plus 1 points of finite discontinuities at 0, 1, 2, and so on. That means 0, 1, 2. Since the points of discontinuity of f on closed interval 0, comma 2 are finite. This is important. Are finite in number. Therefore, f is integrable on 0, comma 2. Therefore, this is f of x here is Riemann integrable. Finite number of discontinuities are there. Therefore, f is Riemann integrable. F is Riemann integrable because it has finite number of discontinuities. Now, second one, g of x is given as 1 for x is irrational, 0 for x is rational. G from closed interval 0, comma 1 to R. Clearly, g of x is bounded. Yes, g of x is bounded because g of x lies between 0 to 1 for all x belongs to closed interval 0, comma 1. If a partition P is equal to 0, x0, x1, x2, and so on, xn is equal to 1. P is written like this. Is any partition of closed interval 0, comma 1. Yes. Then for any subinterval I or else IR, x r minus 1, xr, r is equal to 1, 2, 3, and so on up to n terms. We have supremum is equal to 1. Supremum is equal to 1 here, and infimum is equal to infimum is 0. Now we know that upper Darboux sum of G is equal to summation R run from 1 to n supremum. This is delta R. The delta R means xr minus xr minus 1. Summation R is equal to 1 to n m of R. Supremum of this is 1 here xn minus x0 is equal to 1 minus 0 is equal to 1. Therefore, value of this is 1. Next, lower Darboux sum is equal to summation R is equal to 1 to n infimum of delta R. Infimum into delta R is equal to R is equal to summation R is equal to 1 to n. Infimum here 0 is there. 0 into anything we get 0. Therefore, it is 0. Upper Darboux sum is equal to 1. Lower Darboux sum is equal to 0. Now, lower Darboux integral of g of x is equal to g of x with respect to x is equal to supremum of definition, supremum of lower Darboux sum. This is 0. This is value we get 1. Therefore, lower Darboux sum is not equal to our upper Darboux sum. Therefore, G does not belongs to R of 0, comma closed interval 0, comma 1. Or else G is not Riemann integrable. G is not Riemann integrable. Here F is Riemann integrable. F is Riemann integrable because it has finite number of discontinuities. G is not integrable, Riemann integrable. This is Riemann integrable. This is not Riemann integrable. Where is F is Riemann integrable, but G is not Riemann integrable. This is the answer for this question. Simple question. Remember all what I discussed. Next, practice question for you. The function f of x is equal to x square on closed interval 0, 1 is option A, not integrable, B, Riemann integrable but not continuous, continuous and Riemann integrable, differentiable but not Riemann integrable. If you understand the concept, comment your answer on the comment box. This question for you. Try it. What is the answer? Comment in comment box. If you want to practice these kind of questions, join our Telegram group. Link is in the description. Check it once. Next, KSET 2024 question. Which of the following statement is false? They are asking for false statement. First option is, if f is monotonic on closed interval AB, then f is Riemann integrable. This is true. F is monotonic. Every monotonic function has finite number of discontinuities. Therefore, if a function has finite number of discontinuities, that function is Riemann integrable. Therefore, it is true. If f is continuous on a closed interval AB, then f is Riemann integrable. This is also true. If a function is continuous, then it is Riemann integrable. If a function is uniformly continuous, then also a function is Riemann integrable. Next, if the set of points of discontinuity of a function f on closed interval AB is finite, finite, then f is Riemann integrable. Also, I discussed this in the above question. This is true statement. If the set of points of discontinuities are finite, then function is Riemann integrable. Next, these are all true statement. Remaining one. See, if the set of points of discontinuity of a function is infinite, see, infinite. This is measure of A here is equal to measure of A here 0. Here we cannot say measure of A 0. Therefore, this is false statement. If the set of points of discontinuity of a function f on closed interval AB is infinite, then f is Riemann integrable. This is false. We want false statement for this question. Therefore, answer is fourth one. See, concept is result. A function f from closed interval AB to R is Riemann integrable if and only if, see, if and only if set of points of discontinuities of f has measure 0. That means set of points of discontinuities are finite, then only it is Riemann integrable. Therefore, option 4 is wrong or false. Therefore, correct answer is this one. This is the concept. See, question. If f is bounded on closed interval AB, then f is Riemann integrable if and only if F is continuous. The set of points of discontinuities of F has measure 0. C. F is monotonic. D. F is differentiable. If and only if based on the above statement, I created this question. Comment your answer. What will be the answer for this question? In the comment box, comment your answer. Next, KSET 2021. The value of integral -1 to 2 mod of x greatest integer function of x into dx is. This is a simple question. If you know the graph for modulus of x, this is graph for modulus of x. 0, origin 0, x-axis. This is y-axis. The concept is -1 to 2 integral -1 to 2 mod x greatest integer function of x dx. Now x, split the limit like this: -1 to 0, 0 to 1, 1 to 2. Value remains same for this. That means if this is result, this is one of the result a to c f of x dx. If a function has a limit a to c, then we write limit like this: a to b f of x dx plus b to c f of x dx. This is the result. Remember this. Now, if you split that like this, -1 to 0. Here, -1 to 0. Modulus of x is negative. Next, greatest integer function value is, in this case, greatest integer value is -1 dx plus 0 to 1. 0 to 1. In that case, modulus of x value is greater than 0. That means x here value is GIF, greatest integer function value is 0 plus 0 to 1, 0 to 1 to 2. This, in this case, modulus of x value greater than 0. That means x 1 to 2 value of this is 1. Greatest integer function value is 1. Therefore, this is dx. Now, simplify this. -1 to 0 x dx, minus into minus plus x dx plus this is 0 plus 1 to 2 x dx. Now, we know that integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Therefore, x raised to 1 plus 1 divided by 1 plus 1 means x square divided by 2, -1 to 0 plus this is also x square by 2, 1 to 2. Limit is 1 to 2 or else 2 to 1. Now apply upper and lower limits. This becomes 0. this value becomes 0, minus 1 by 2, this value is 4 by 2, means this is 2, this value is minus 1 by 2, minus 1 by 2, minus 1 by 2 becomes minus 1, this is 2, minus 1 plus 2 is 1, answer is 1. Where is C? Option B is the right answer for this question. Next, KSET 2021 question. See, I already told in previous video, I will discuss this question in Riemann integral chapter, Riemann integration chapter. Therefore, I taken this question. Let f of x is equal to limit integral sin x cos x e raised to t square plus xt dt. Then f dash of 0 is equal to derivative on integral sign. This question is based on derivative on integral sign. See, this is Leibniz rule. Integral limits psi of x into pi of x, psi of x to pi of x, f of t dt is equal to this d by dx f of pi of x d by dx of pi of x upper limit minus f of psi of x derivative of psi of x means lower limit plus derivative of integral psi of x pi of x differentiation of f of t dt. This is Leibniz rule. If you apply this for this question, see pi of x, f of pi of x upper limit. Therefore, e raised to, in place of t, replace upper limit, replaces by upper limit. That means cos square x plus cos x into x. Derivative of cos x is minus sin x minus e raised to sin square x plus sin x into x. Derivative of sin x is cos x minus plus at, this is at x equal to 0 because f dash of 0. They are asking f dash of 0. Here sin of cos of 0 is 1, sin of 0 is 0, d by derivative of x e raised to t square plus xt dt. First integrate, then put value at x equal to 0. That means if we integrate this, we get, if you differentiate this, we get e raised to t square, into 0. This becomes 0 because we put 0 here. Next, this value is 0. This value is cos of 0, sin of 0, 0. Cos of 0 is 1. Therefore, minus 1 plus integration 0 to 1. This becomes e raised to t square into t dt with respect to dt minus is equal to minus 1 plus integration 0 to 1 t e raised to t square dt. Now put t square is equal to u, 2t dt is equal to du. T into dt is equal to du by 2. That means minus 1 plus integration 0 to 1 e raised to u, because I taken t square is equal to u, e raised to u du by, in place of dt, du by 2. Simplify this, we get e minus 3 by 2. E minus 3 by 2. Now, where is the answer? E minus 3 by 2. C. Option C is the right answer for this question. Pause the video. See carefully. You get this question. Next, KSET 2020 question. Which of the following statement is false? They are asking for false statement. Option A, if f is bounded and has finitely many discontinuities on a comma b, then f is Riemann integrable on a comma b. This is true statement. We already saw the result. Next, B. If f is monotonic on a comma b, then f is Riemann integrable on a comma b. This is also true, because every monotonic function has finite number of discontinuities. Therefore, this is also true. Next, if f is continuous, every continuous function is Riemann integrable, then f is Riemann integrable. This is also true. Remaining one is the answer. If f and g are not Riemann integrable on a comma b, then f into g is not Riemann integrable on a comma b. This is false statement, because this is false, because if we take one, if x belongs to rational, minus 1 if x belongs to irrational, f of x is equal to this. Same function, g of x is same, f of x into g of x, f into g is equal to 1. This is Riemann integrable. Therefore, this is not Riemann integrable, not Riemann integrable. This is also not Riemann integrable, but this is Riemann integrable, because this is continuous function. This is Riemann integrable on a closed interval a comma b. See result. If f is Riemann integrable over a closed interval a comma b and g is Riemann integrable over a comma b, then f into g is also Riemann integrable over closed interval a comma b. But converse is not true. Here f is not Riemann integrable. See, but converse is not true. If f into g is Riemann integrable over a comma b, then f and g need not be Riemann integrable over A comma B, they made a question based on this result in converse way. See, for example, f from 0 comma 1 to r be defined by f of x equal to minus 1, x belongs to rational number 1, x belongs to irrational number. F is not Riemann integrable, but f square, f into f square is Riemann integrable. Therefore, this result, based on this result, question is made. See, this option is false. Therefore, answer for this question is D. Next question is 2018 question. See, limit n tends to infinity, Cartesian product k from 1 to n cos pi by 2 raised to k is equal to what? This is limit n tends to infinity. If we take value cos of pi by 2 into cos of pi by 2 square into cos of pi by 2 cube and so on. Cos of pi by, we know cos of pi by 2 is value is 0. Limit n tends to infinity. This is 0. 0 into anything, cos of pi by 2 square and so on. Value is 0 here. 0 as n tends to infinity. Therefore, option C is the right answer. Simple question. Next. This is also a KSET 2018 question. 1 by pi integration minus pi to 5 x raised to 5 cos 5x dx. This is also simple. F of x is equal to, here given, x raised to 5 cos 5x. See, f of minus x is equal to minus x raised to 5 cos of minus 5x. We know that cos minus x is equal to cos x. X raised to minus 5 is minus x raised to 5 because x raised to minus 5 is minus x raised to 5. Therefore, this is cos 5x. This is odd function. F of x is equal to f of x. F of minus x is equal to minus f of x, means function is odd. If a function is odd, we know that its value will be 0. Therefore, option D is the right answer for this question. Odd and even function. The question based on odd and even function. Simple question. I hope this video is useful for you. If you like the video, hit the like button. Subscribe this channel for more videos. If you want to practice more questions, join our Telegram group.